Thank you also. Thank you all for coming this morning. I'm very happy to introduce our next speaker in the Cardamom Seminar series. So Annemarie Verkerk is a professor at the Saarland University, looking at language diversity and typology. She's going to look at here is the role of information in cross-linguistic modeling. So without further ado, Annemarie, if you're ready to start.
Yeah, I'm ready. Can you see?
Thank you. We can see
Can you see my screen?
Yes.
Okay, great. So hi, thank you very much for having me, and thanks for the nice introduction. The title of my talk today is Cross-linguistic Modeling of Communicative Efficiency. I'm going to present basically our future projects on this topic today. So in order to do that, hold on. In order to do that, I'm going to talk about dependency length, the efficient memory-surprisal trade-off, and how information structure comes into all of this in the introduction. Then I'm going to discuss themes of our project, the corpus that we're building, and our methodology of annotating it. I'm going to talk about future aims for the coming 4 years in this project, and end up with a case study on one of the later aims in the project, which has to do with the interaction between variable word order and case marking. So I want to start today on the premise that the only thing that is universal in human language is that it's rooted in communication and therefore displays certain characteristics. So for example, language has shared rules with which we can create sentences and new words. And without these rules, we cannot make ourselves understood. If the rules wouldn't be shared, then we couldn't use our individual languages for communicating. So from this principle that language is rooted in communication follows that language is also efficient. This implies that speakers wish to communicate in a way in which they don't spend too much effort to bring their point across in such a way that is also well understood. So this principle explains many findings about language, such as the Zipf's law of abbreviation, stating that frequent words are short. It also explains Levi and Jaeger's uniform information density hypothesis, which states that human languages present a more or less constant flow of information when you're talking or when you're writing. So just how efficient languages are has been a topic of linguistic investigation, which has especially increased over the last 10 years or so. And the paper in the bottom right corner gives a good and recent overview of this research. And the project that I'm going to talk about today will start this summer and will address the question of what efficient language uses as well, right? So it's also within this larger topic of language efficiency. So we don't have results for you guys yet, but we hopefully have some very nice ideas about how to go about researching our particular questions that you will be interested to hear about. To start with some background, linguists have long studied the hierarchical structure of sentences and grouping of words into constituents. Words and constituents are not ordered randomly, but ordered such that dependencies between them, in other words, dependencies between heads and their dependents, are as short as possible. So this has been researched both historically as well as using more recent approaches to computational or corpus-based typology. On the left, you see a figure from one of the first papers showing such effects. This is Futrell et al. 2015. So these guys took corpora from different languages that were parsed with dependency grammars and scrambled up the dependency relations. In all of these cases, the dependency lengths of the scrambled corpora are longer than those of the real corpora, showing that the sample languages optimize dependency length. And on the right, you can see an example from our corpus displaying how dependency grammar works and how languages may differ. Both of these are translations. We have a translation in Greek and we have a translation in German. And the original sentence is, I've got to pick up a new book on vampires myself. So German translates this as, Ich muss auch noch ein neues Buch über Vampire abholen. And it has really long total dependency length for its translation because German has V2 in declarative sentences and we have really big dependencies between the subject and the auxiliary verb all the way to the main verb at the end of the sentence. So modern Greek does quite a bit better, right? The verb is in the middle and dependency relations are in total. If you sum over them, they are much shorter. Building on what we know about dependency length minimization, Han et al. 2021 present the efficient memory-surprisal trade-off, which states that a reasonable, which is a low enough level of surprisal, can only be efficiently achieved if relevant contextual information is stored. But this comes at a cost for memory, which languages carefully have to balance. So in order to kind of unpack that idea, we first have to have a look at surprisal theory. So surprisal can be interpreted as the quantification of the level of surprise of an event on the basis of probability. In the example on top, or a set of examples on top, we have annotated these words with trigram surprisal of lexical items of words. And these examples show us that if we calculate surprisal in this way, surprisal tends to be high in the beginning of sentences and then lower as the sentence progresses. And this basically tells us how likely each of the words, how likely the word is to appear given the preceding context. So the surprisal of a word can be equated to the difficulty, to the processing difficulty of that word. So this has been shown both using behavioral measures such as reading time and pupil dilation, as well as the N400. So to come back to this idea about the efficient memory surprisal trade-off, intuitively, if a listener or reader has more information about the past content, he or she can make better inferences about what is coming next. So that means that they would have a lower surprisal. However, this comes as a cost for memory, as I already said. So previous information obviously has to be stored. And this is the reason that long dependencies are disfavored in human languages, because they require a larger reliance on memory. That's the basic idea that they present in that paper. So Han et al. In that paper, you can see in the bottom right of the slide, they calculated the trade-off between surprisal and memory. And again, they used an approach similar to Verkerk et al. So they use real corpora and they use scrambled corpora data. And then they find that the real data have a better memory surprisal trade-off in 50 out of 54 languages they looked at. But if we step back and take, well, kind of zoom into each of these results and some other ones as well. So let's take Verkerk et al.'s results first on the left. While it is true that dependencies in the corpus data in blue are shorter than expected with a scrambled version of the corpus in red, there are cross-linguistic differences in how optimal dependency lengths are across languages. So taking these 4 languages on the left, we can say that Latin and Hungarian are less optimized than Hindi and modern Greek, and Greek is the closest to the theoretical optimum, the green line. The same applies to Han et al.'s work on the surprisal memory trade-off. Here we have another figure on that in the middle of the slide. So I just explained that they compare the trade-off curves for the real orders with those for random baseline grammars for 54 languages, and find that real orderings tend to concentrate more predictive information in the immediately preceding word than baseline grammars, so they perform better. And there are 4 exceptions to this. I said this works for 50 out of 54 languages. So there are 4 exceptions, and these are Latvian, Polish, North Sami, and Slovak. So looking at an explanation for that, they find that word order freedom impacts the memory surprisal trade-off, so that languages with more strongly fixed word order display a more optimal memory surprisal trade-off than languages which don't have such a fixed word order. So free word order is generally associated with coding information structure. And in a case study on Czech, Han et al. 2021 still find that when they include information structure in their modeling, branching direction variability decreases, while the surprisal difference between the real and scrambled orders increases. So in short, if you model information structure in this type of approach, you get a better fit of the model. So information structure matters, especially for languages with variable word order. And then lastly, on the right, we have recent work by Ying et al., who find that dependency length minimization is inversely correlated with the overall presence of head final dependencies. So in the figure on the right, we have red colors that indicate that observed dependencies are more often shorter than expected under the baseline model. So these suggest effects from locality, while blue colors indicate that they are more often longer than expected. And then they find that blue colors are associated with languages that have more head final word order. So hence, as Verkerk et al. Already remarked in 2015, languages with SOV word order are less prone to dependency length minimization effects. And this extends to other head final word orders in language. So on the previous slide, we identified 3 factors that impact dependency locality and in turn the memory surprisal trade-off, namely word order variation, head finality, and information structure. So these topics they are of course related to one another, right? It's well known that many languages, including the exemplified languages here on the slide, Walpiri and modern Greek, word order is far more flexible in them than in English or German, for example, right? And in both cases, word order is structured along lines of information structure, which can be defined as the management of old, new, and contrasted information within sentences and larger chunks of discourse. In world theory, word order revolves around focus. So whichever element which is in focus, that means that it's new in relation to previous discourse or newsworthy in general, this element comes first in the sentence. And in addition, in actual world theory discourse, given constituents are dropped, so that transitive word orders with both subject and object present, as we have in sentence B and C on this example, they are actually pretty rare. And in modern Greek, there's a tendency to use SVO word order, but all other word orders are allowed. For example, we have examples there on the slide. There's emphatic or contrastive stress that you can mark by putting certain constituents at the front of the sentence. As a further example, we can look at English, which is a language with a fixed SVO word order, and contrast it with Hungarian, which is a topic prominent language. So the fragment here on the slide is taken from Harry Potter and the Philosopher's Stone, which is part of the corpus that will be introduced later on. Glancing at the English original, we see a lot of subjects. They are coded in red. Many of these are pronominal. Then we have these red elements are typically followed by verbs. These are in blue. And then we have objects of different types that follow the verb in green. And at the end of the fragment, we see several constructions that English uses to manage information, like the existential predicate "there was" and the "it was" construction in the last sentence. So on the other side of the slide, we have glosses for 3 Hungarian sentences, so 3 Hungarian translations. So we have the original English sentence in bold on the left, and then we have the translation in Hungarian on the right. So Hungarian, first of all, is a null subject language, and it doesn't require overt pronouns. So there's a lot less red. And the position of the verb, if you can kind of look at that really quickly, it's mostly final in these examples, but it can also be in front of the object. Looking at the nominal arguments in Hungarian, we can see that these are not ordered in the same way as English does. So in Hungarian, nominal arguments are typically ordered on the basis of prominence regarding information structure, such that topics and foci precede the verb and the rest follows. So for example, in the first sentence there, we have a given NP, which follows the verb, while in the clause that follows it, we have a topic NP that precedes the verb. And then in the second sentence, we can see that both topic and focus arguments can precede the verb. And in the third and last example, we have this NP mocus, which is a proper name, which stands in focus position in front of the verb. So Hungarian clearly organizes constituents very different from a fixed word order language like English. And if we want a comprehensive analysis of communicative efficiency in terms of dependency length and in terms of the memory-surprisal trade-off, we need to incorporate information structure. So how do we set out to do this, right? The project that we are embarking on is part of SFB 1102 here at Saarland University, which was just granted funding for 4 more years, in which so this project will actually take place. And we heard about this last week, so yay for that. So the SFB at large centers around the question whether information density in theory can contribute to a unifying model of language use, variation, and change. And in our sub-project, which is by far the most, let's say, cross-linguistically oriented project, our main aim is to investigate communicative efficiency from a cross-linguistic perspective, focusing on fitting models for dependency length minimization and the memory-surprisal trade-off, while taking into account information status and word order variability. So in order to do that, we want to determine how much of the fit of these information theoretic models is dependent on cross-linguistic differences in word order variability. And since we know that word order variability is associated with encoding information structure, we want to investigate what role information status plays in dependency length minimization and make an explicit contribution to investigating the connection between information theoretic concepts like surprisal or information density to information status, which is more core principle in traditional linguistics. And lastly, we want to model diachronically the interaction between overt morphological marking of syntactic arguments and word order variability again. So word order variability is really quite central. So I've been saying a lot of we and our, and so I'm mostly talking about Luigi Talamo, who is also here today. And the two of us have started work on preparing this project in the late 2019, and now we're very happy that this project can actually take place. So all of this is shared work with him, and we will also collaborate with Michael Hahn, who is the person who proposed the efficient memory-surprisal trade-off. And we have started collaboration with Natalia Levshina on word order variability, which we also report on today. On the fourth point, we want to have this wider perspective on communicative efficiency, incorporating morphological marking of syntactic arguments. We will probably use the parallel Bible corpus for that and collaborate with Robert Oestling and Bernard Welchli. I couldn't find a nice picture of Bernard, so I took one of his best cited works, which is his book on co-compounds and natural coordination. The next question, of course, is how, right? How do we aim to do all of this? And central is a corpus-based approach, which is, of course, also central to all of the work I've discussed so far, right? So all of the work that I've discussed is either uses corpora or uses tree banks or both. So in our case, however, we are not using existing corpora or tree banks, but we are building our own parallel corpus, and we parse it and annotate it. So we have called this corpus the Parallel Corpus of Indo-European Prose Plus, CIEP Plus for short, and it has been specifically designed to help us reach our goals. So we take a sample of 33 Indo-European languages, which allows us to do diachronic modeling, but which also allows us to investigate a wide variety of languages when it comes to the topic at hand. We find both, so there exist both Indo-European languages with a very fixed word order, but also with a very variable word order, and also the role of information structure in different Indo-European languages is has a pretty wide range. So in order to expand our focus and to be able to compare our work to that of others, we add a variety sample of 10 non-Indo-European languages from 9 different language families. And again, these are picked to be varied, right? As we already saw, Hungarian is a topic prominent language, so is Chinese, for example. We pick Arabic, which has verb initial word order, and so on. So the corpus itself consists of 18 highly popular fiction and diary works. And if translations of all 18 works are available for a language, that subcorpus contains about 2 million tokens. This is not, it's not the biggest corpus ever, but it's actually also not small, looking at the different subcorpora. We are well on the way with acquiring the material and parsing it. So far we have about 2/3 of the material kind of ready with respect to the initial type of annotation and parsing that we want to do. This is our selection of works for CIEP Plus. So as you realize from this list, we have chosen this selection of novels plus Anne Frank's Achterhuis, which is of course a diary, because they are widely translated and because they originally were written in 8 different languages. So this increases ultimately the number of people that were involved in creating the material and makes it less susceptible to the idiosyncrasies of individual authors and translators. So there are many problems with data collection. I will talk about copyright in a second, but some of the issues that we deal with are as follows. So we have books that have been published, but that you cannot buy. So for example, there are certain translations of the first Harry Potter book that are collector items. They've only been printed 500 times or so, and they cost hundreds of euros, but they're not even for sale. So even if you had this money, you wouldn't be able to spend it. So in other cases, we have translations that are published in places without a proper national library, and even the most extreme example we deal with book burnings in the case of Achterhuis. Then there's lots of abbreviated or abridged translations. This is especially a problem with Alice in Wonderland and the Little Prince, because these are sometimes thought to be aimed at children. Then we have translations that have otherwise been changed. For example, in translations from the Islamic world, we have translations that have changed the kissing scenes in Harry Potter or cut them out altogether and stuff like that. Then there are huge problems, or well, not problems, issues with the conversion process. So what we do is we buy books, we OCR them, we hire native speakers to correct the OCR mistakes. And this takes about a year for a part-time student assistant who can work pretty fast on a language that's written in a Latin script. But for non-Latin scripts, OCR tools are simply not as well developed. So there's lots more mistakes. So we are using a combination of free, we're using a combination of ABBY for Latin scripts and Tesseract and Google, which is free OCR, and lots of man and women power to do this. But we are also wondering whether for some languages we would be better off using a computational approach to correct mistakes that show regularity. So one of course will say, why, if this is so hard, why not use the UD tree banks? But since KEEP Plus is a parallel corpus, this implies that we're dealing with translational equivalence. And this has a clear benefit, for example, over the universal dependency tree banks. These are not parallel, and often they don't even contain material from the same register, nor are they of the same size, which makes comparison actually far more indirect than we would wish for. Secondly, we are dealing with highly popular novels, which ensures high data quality. So these were all books that were created and sold to make a profit, so they're pretty high quality. So we believe that creating KEEP Plus is a valuable enterprise, and it falls under creating resources that are relevant and necessary in order to conduct research. So we should also talk about copyright, right? Since we are in Germany, we have to abide by German copyright law, which is called the Urheberrecht, which you can see on this slide. And so the Urheberrecht affects the right of reproduction, the right of distribution, and the right of making works available to the public, and several other related rights which are less important for us. So since 2018, we are now in a lucky position in some ways, because we are now allowed to share copies of copyrighted work, so including digital copies. This wasn't actually allowed before, because this is seen as a type of reproduction. And we are allowed to share the data in closed circles, including for peer review. However, making the full corpus publicly available is not allowed, right? So for replication purposes, we aim to make available a smaller version of the corpus in a derived text format shape. And I'll explain what I mean with that in a second. Then, of course, it's been now over 2 years, and we will continue creating KEEP for a long time. And all of that is associated with a pretty high cost in terms of the time and money spent on that. So we hope to kind of keep KEEP Plus alive by using it for further projects, because otherwise we are forced to store it somewhere. We are not allowed to just put it on the Zenodo or something like that. Yeah, which would be very helpful to do, but we are not allowed to do that. So what we want to do is publish something that we will call Mini KEEP Plus, which would be a publicly available parallel corpus in 50+ languages, where we take a small subset of each subcorpus, we sentence align that small bit. So this would probably be a chapter from each of the books, and annotate it fully with UD dependency grammar, UD dependency parsing, as well as information status. And then we necessarily have to do this as a derived text format, which means that we have copyrighted corpus materials, and these would be distorted or annotated in such a way that they constitute original works. So we could, for example, take out all of the names and replace them with this kind of placeholder, which is name or something like that. Or, there's other ways to do it as well, which even disturb the original material even more. The only problem is that it's unclear if this is possible. So this is all kind of in a gray zone regarding copyright and using text material in the digital humanities. And there's been publications that say, well, actually you can manipulate such text-derived formats to retrieve the original materials, and then you are still constituting copyright violations. So we have to see how this will go, but we will definitely we will work on this in the second half of this year, and hopefully find a solution that is legal and that will allow us to share a big chunk of the work that we have done so far. So what will we do with KEEP Plus in order to be able to research it? So this is an outline, and I'm going to go over details in the rest of the talk. So what we do is we parse the text, right, which is just plain text format, with language-specific dependency parsers that are available through the Universal Dependencies project. This is represented by the top bar in gray. This is what the native conlu format looks like for the universal dependency grammars. Then we aim to annotate the entire corpus with annotation for information status, and we will use a simplified scheme of given, new, accessible, and contrastive. So annotation of information status in the English part will be generated first automatically and then corrected through crowdsourcing, and then we train English-speaking crowdsource workers to annotate English texts using existing core guidelines on annotating information status. And then, of course, they only have to do that for NPs and PPs that refer to discourse reference. Then the information status annotation needs to be mapped onto the other subcorpora. In order to achieve this mapping, we need sentence alignment, partial word alignment, and then annotation projection. So at the bottom, you see the first sentence of the German fragment translated into Czech, Turkish, Finnish, and Arabic. This is kind of a sample of what that would look like. So kind of flowing down of the annotation. But this is only an illustration, and I'll go over a little bit more detail now. So ultimately, CIEP+ will have multiple layers of annotation. Of course, we have metadata. We have dependency parsing using the UD framework, and I've said this, I think, 10 times now, and I'll explain what that is in a second. Of course, we'll have information or annotation about information status, surprisal, probably several types of surprisal coding, but also other types of information theoretic analysis, and named entity recognition. And to this, we may add co-reference resolution, and I'll come back to that later. So CIEP+ has this modular structure with a pipeline of Python scripts producing and combining different layers of annotation, starting from UTF-8 encoded text files. For tools, we are using the Python library Stanza to parse CIEP+ using universal dependency models, which outperforms other parsers as far as our experience is so far. So we use CQP Web to be able to query several layers of annotation at once, and we will use other tools for sentence and word alignment, and I will explain that in a minute. So far, I've mentioned this universal dependencies framework or project several times, and I haven't really explained now what it is. So you can see on the slide, there's this quote. So universal dependencies is a framework for consistent annotation of grammar, which has to do with parts of speech, morphological features, and syntactic dependencies across different human languages. UD is an open community effort with over 300 contributors, producing nearly 200 tree banks in over 100 languages. So I think this is probably outdated because they just had an update 2 weeks ago, and there's now, I think there's at least 140 tree banks in there, or tree banks in 140 different languages, I mean. So, but we're not using the tree banks themselves, right? We're using these to train parsers that parse our CIEP+ data. So we have to worry a little bit, of course, about the quality of the syntactic parsing. So far we have been investigating this with respect to word order variability. Natalia Levshina has also investigated this, and so far the data from parsed corpora and UD tree banks seem to be highly correlated. But nevertheless, there's noise that we have also found about, and there's two kind of solutions on different levels that we want to take in this regard. So for smaller languages, the problem is that the tree banks are simply too small to train parsers on. So we will need for some languages to retrain parsers with additionally manually parsed data and dictionaries. And this is definitely an option for some languages and possible with external funding and external collaborators. And this is something that we want to explore in the coming months to see. So for example, for Punjabi, the tree bank is simply too small. So how can we make it bigger so that we can parse CIEP+ with it? And then for queries, there is a possibility to rely on multiple annotation layers rather than one. We have a paper on that coming out, and Luigi will also present on that in SIG-type, which is coming up. Then I've already mentioned information status several times without explaining what I mean by that. And of course, information status has to do with the shared knowledge that speaker and interlocutor have. So this is therefore the basis of more specific labels that we might find in information structure annotation, right? So just topic and focus. We want to stick with something quite basic which has to do with this idea of shared knowledge, and which is also independent of the type of marking constituents receive across the world's languages, because we feel that the adventure is already quite big enough. So the idea is to annotate using a simplified version of the reflex scheme for information status annotation by Riester and Baumann that you see on the slide here. So we kind of collapse some of the categories that they have here into given, new, and accessible, and then possibly also contrastive. And we don't code for non-referring expressions at all. So that's one of the categories that they have lower down in the table. So here we only have to concern ourselves with the information status of reference MPs and PPs that refer to discourse reference. So people, things, events that are coded with NPs or PPs in the sample texts. So as I already explained, so far we aim to create information status annotation for the entire corpus. And this is actually a pretty big venture. So the way that we want to go about doing is making use of the fact that CIEP plus is parallel. So we want to gather in annotation for one subcorpus. So I've already said that this would be English, but we're also kind of figuring out if that actually shouldn't be, if the primary annotation shouldn't be for the individual original texts. And we have to do pilot studies on figuring that out. So we want to do the annotation for one subcorpus, so either all the original texts or the English subcorpus, and then project that information onto the other corpora. And we aim to do this using this kind of hybrid approach to crowdsourcing information status annotation. So first, we build on this kind of general rules of information structure. I mean, these are principles, and I have an overview of them later on a slide. Like pronouns are always given, proper nouns can be given after they first appear. For a certain amount of context, certain protagonists like Alice in the work by Lewis Carroll, they're always accessible. And, things like definite NPs, they're typically given, and so on and so on. So we can build on these general ideas to come up with kind of a first parsing, and then split the annotated base, or the base annotation. So split the corpus that has this base annotation up into shareable parts, which would be paragraphs, and crowdsource the correction of the automated annotation. And therefore, there we would focus on, parsing the PPs and NPs correctly, correct the automated information status annotation, and add information about contrastive and emphatic focus, which you can actually really only get as a human, right? You can't, I don't think you can build something that gets you that. It's really too hard. So yeah, and for the crowdsourcing, we have actually quite a bit of experience within the SFB 1102 that people have done crowdsourcing for annotation before. So we will build on that. So at least we have some experience within the bigger context of the project. So then, of course, if we want to do annotation projection, we need good sentence alignment, and we need partial word alignment. So there's lots of state-of-the-art tools for sentence alignment, but most of these are, they concern themselves, it's purely seen as an NLP task, right? They concern themselves only with optimization and not really with practical applications. So far we think that VecAlign will be most interesting for us because these support a really wide range of languages. And we will use VecAlign or another tool to sentence align the English subcorpus with all of the other subcorpora so that we can transfer information status annotation ultimately. And of course, we would do the same for mini-CIEP. We have to see how these two main tasks kind of work together, or we can work on them in parallel. Then we also obviously need word alignment. So there's lots of state-of-the-art tools, but mostly people concerned with optimizing these, with creating state-of-the-art tools, but not really that much practical usage as far as I can tell. So we need that for the annotation projection, but we only need it for the NP and PP discourse reference, because that's actually the only part of the material that will receive the information status annotation. So we only need it there. And we actually think that it's probably easier to have word alignment of NPs and PPs than it is of some other types of constituents. Then once sentence alignment and partial word alignment is in place, we can do annotation projection. And the figure on this slide here kind of explains how this is done. Within this example, they have this example there that they use is semantic roles being transformed or added through to word alignment. So the idea here is that we have sentence word alignment, sentence and word alignment, and that leads to annotation projection, or at least enables that. And then we would still obviously have unaligned NPs and PPs, right? So these could be words that are newly introduced in the translation or that otherwise remain unannotated. And here we would again make use of the universals of information status. So you would have for each language an automated parser that labels these NPs and PPs for which annotation projection doesn't work. And this is something that we want to work on using external funding and also student projects, so that we can also check some of this automated parsing in different languages and see how well it works and what kind of characteristics languages have in this regard. And then we also have an alternative, or perhaps in parallel to annotation projection, would be to do language modeling to achieve our goal of information status annotation for all subcorpora. So here the input would be parsed sentences, where we have the universal dependencies, parsed sentences, and we create training data, right? So the conlu format allows for one extra column where we could store annotation on information status with these labels I've already talked to you guys about. So given, new, accessible, and contrastive. And these would be generated by humans, right? We would annotate a part of the corpus and then ask the model to learn the context in which these labels apply. So that probably means that it has to look at the preceding context within the sentence and also the previous sentence for co-reference. And the output would then be the same, we still have the universal dependency parsed sentences with automatically inferred information status annotation in the extra column. So that's the most basic version. And we are also considering to base this on previously applied automatic annotation. So for example, coming from the universal anaphora or the co-reference in universal dependencies projects. So these are relatively still new and relatively, let's say, untested by people for outside of the project. So we have to see how that goes. But it would be wonderful if the model had access to both dependency parsing and anaphora or co-reference information to do the modeling. So basically, getting the information status annotation is a major part of our project and something that we will start with straight away in July. So of course, once we have all that, what will we test, right? What will come out? This is quite a sensible question to ask, maybe even 10 minutes ago. So regarding dependency length minimization, our hypothesis is, of course, leading from Futrell et al. 2015, that the idea that if a language allows longer dependencies, these are associated with the notion that information structure and not only syntactic rules govern word order. So we expect that languages that allow for longer dependencies, so that display less dependency length optimization, have certain properties that have to do with information status. And here we will especially focus on which word orders allow for long dependencies and which don't. So we try to make this a bit more, linguistically informed, let's say. And then regarding the efficient memory-surprisal trade-off, the idea here is that Han et al. 2021 finds some languages that do not display a more optimized trade-off as compared to the scrambled corpora. So this suggests that there's something about these languages, including Czech, for which we have an example on the slide, that is not captured by exclusively looking at dependency relations. This is because word order is relatively free in Czech and languages like it, but not if we add another perspective, right, that of information structure. So word order rules in these languages are governed by information structure management and not by syntactic word order rules alone. And in order to test the efficient memory-surprisal trade-off in Czech and other languages like it, we need to incorporate an annotation on information structure when we make the baseline grammars to compare the actual corpora to, because word order carries information about information structure, not just dependency relations in these languages. So we hypothesize that if we do that, the memory-surprisal trade-off will hold in Czech and also in other free word order languages. And we are actually quite curious about the impact it will have on other subcorpora. Right, we are running out of time. And as the last part of this talk, I would like to talk about a recent pilot work on the relationship between word order and other variables. So we have on this slide some processing-based explanations of phenomena in language, some of which you can see on the left. And these have played a major role in typology for investigating the relation between what overt morphology and syntax. So people have stated that, verb final word order implies dependent marking, zero marking languages prefer SVO word order, free word order implies case marking, and so on and so on. However, these proposals have disregarded word order variation and its corresponding functions in discourse altogether. So you get these labels like SVO, verb final. I mean, what does that actually mean, right? Does that also apply to languages which have mainly SVO, but also other word orders? These are open questions. So recent work in which we have been involved has demonstrated the value of relinquishing these categorical labels in favor of more gradient measures. And in this project with Natalia Levshina, we investigate the interaction between word order preferences and variability, so with word order and head and dependent marking from a diachronic perspective. So our case study investigates cues that languages have to distinguish between the grammatical subject and object. In this paper from 2021, Natalia analyzes the dependencies between 4 strategies that can be used to distinguish subjects from objects. So we have case marking, tight semantics, that is how strictly words are associated with the grammatical role of subject and object, rigid word order, and having the verb in the middle. So having the verb in between the subject and object, so verb medial. And her results are presented on the right. She finds that the strongest negative correlation is between case marking and word order. This implies that distinctive case marking increases with word order flexibility and decreases with word order rigidity. There is a positive correlation between case marking and tight semantics that suggests that semantically tight languages tend to have more informative case marking than semantically loose ones. Again, a negative correlation between case marking and the proportion of verb medial, which means that languages without distinctive case marking tend to have SVO. And the last significant correlation is a negative one between semantic tightness and the proportion of verb medial, which suggests that semantically loose languages are usually verb medial, whereas semantically tight ones are usually verb final. So this is it's a pretty complex story because all of these variables are interacting with one another in one way or another. So she proposes in the paper a causal and diachronic account of the correlational results, which is quoted in the green box on the left. Basically, she concludes that a diachronic scenario involving influx of second language learners could cause these typological correlations, but this has very little to do with communicative efficiency in a speaker-interlocutor setting that people have mostly talked about in this type of context. So it has more to do with a preference for this rule-based linguistic systems and the avoidance of morphology as displayed by second language learners. So in this pilot project with Natalia and Luigi, we aim to investigate these cues from an explicit diachronic perspective. So in order to replicate this work, but actually take an explicit diachronic perspective, we have started to work on the analysis of the same variables using CIEP plus, well, just the Indo-European part, so we can just call it CIEP, parsed with the UD dependency parsers in 30 Indo-European languages. And so far we have studied the distinctiveness of case marking, which we have approximated by analyzing lemmas that appear in both subject and object roles and seeing if these are identical or not. And we have looked at the entropy of the verb in relation to nominal arguments, so if the verb is in medial position or not. So both of these measures are a bit crude and we will revise these as we go along. When we take Natalia's data from the 2021 paper and model diachronic change on the branches of an Indo-European tree, we model the correlations on the branches of an Indo-European tree. There is very strong correlations between case marking and rigid word order of subject and object, and secondly, between tight semantics and verb medial. And there's a strong phylogenetic signal there. That means that the data fit well on the tree. And we want to focus on case marking and verb medial, or rather, verb entropy, verb variability, with respect to several other constituents, using a so-called lag analysis. So this test is for correlated variables like these are, and investigates whether one of the two variables changes slower than the other, causing evolutionary lag. And this is not a strict causality test, so we won't know if word order changes are caused by changes in case marking or vice versa. Of course, we would like to know, right? But this test can be suggestive of the diachronic order of change. In other words, we can find out which variable changed first, and then we can, we would infer from that the other changed or might change in response to changes in the first variable. So right now we don't have any final results yet, but first analyses suggest that verb mediality kind of lags behind change in case marking, and this would actually fit with the hypothesis or the scenario that Natalia wrote about in the 2021 paper, because second language learners like myself in German, we just, we get rid of case one way or another, and then verb mediality, so changes in word order with regard to the verb kind of follow after that. So ideally, of course, we use a greater language sample than 30 languages, and this is one of the things that we'll work on in the coming months. Here comes kind of the outlook. We have a kind of a project kickoff, not really. So this project will start on the 1st of July. We are looking for a PhD student that can tackle basically all of the computational and corpus linguistic aspects of getting all of this annotation for an information status that I talked about. So if you have any ideas about that, we would be very pleased to hear them. Look out for some further talks on this on our project this year. We have a further report on the case study that I just mentioned at ITCHL. We have another project using CIEP+, which has to do with the diachrony of subordinate clauses at SLE. And we have work by Luigi on word order variation in a noun phrase at SIG-type. Also look out for a first publication using CIEP+, in order to investigate word order variability in the Italian Journal of Linguistics. I'm saying later this year because then it might happen. And mini-CIEP is to hopefully follow sometime in 2023. We are very happy to hear from you on any topic that you might think we could collaborate on, basically. So we are just starting and hoping to build a good network of people that will help us tackle all of the things that we want to tackle in this project. Thank you very much for your attention.
Okay, thank you very much for the excellent talk, and I'll just say congratulations on your project. It sounds really interesting.
Thank you.
Good. Do we have some questions? If you want to raise your hand or put it in the chat. Maybe I'll start. So I think one of the really interesting things, we've been looking at morphology in a diachronic context, not so much in syntax. And as you're probably aware, many of the models that are used, now are these deep learning models, which are kind of, fairly sequence orientated. So I was wondering, do you know if there's any work on sort of building these kind of information theoretic constraints into, so we say kind of deep learning approaches, or into more kind of computational approaches like speech tagging or something?
It's a tough one. Not really. I don't know, but that doesn't really tell you very much that I don't know it. I mean, like the work that we have been doing so far is pretty syntax oriented, and I can't think of anything from the top of my head. Okay. But that doesn't mean that you guys shouldn't create it, right?
Yeah, it seems interesting. It seems like there's some use in this kind of information theoretical approach. When we're doing this, particularly with low data where we rely on unsupervised things, you need every kind of guidance in terms of order. So it'd be very interesting if you look in, if we move beyond morphology into syntax, I think it's very important.
I mean, I know there's some work on, so I had a student last semester who worked on doing phylogenetic inference with the help of information theory, in the sense that he built models that looked at the patterns in related phonemes across words in a lexical data set, in a cognate data set, and that actually helps a lot. So I bet that if you have something like paradigms and stuff like that, but then of course you already need quite a bit of data. I mean, of course the lexical data is not so big that you typically have, and that helped the analysis. So we got better performance taking that information on those patterns. But then with paradigms, with morphological paradigms, you might have so much other stuff going on that it might be really tough to get something out. I don't know. I don't have clear intuitions about that.
Okay, thanks. So Stanislava has a question. I don't know if you want to ask it yourself or.
Well, I suppose I could. I mean, I sort of in my previous life come from the information theoretical approach to paradigms, actually, in Serbian case system, for example. But then I moved into other things. So what I found interesting, and you didn't really say much about, is surprisal coding. Kind of stopped at the information status, but then it would be interesting to know how you calculate surprisal coding and what you do with that.
So, I mean, what we have done so far is really quite simplistic, that we take trigrams and calculate the surprisal of words on the basis of that, trigram probabilities. And one of the things that we have worked on, and we've actually also presented on in the last year or so, is this idea that surprisal correlates with givenness. So we looked, for example, at pronouns versus proper names and their surprisal, but also their position within a sentence. And it was really hard to kind of get something out of there. So this very simplistic idea that givenness has something to do with low amounts of surprisal, like very simplistically thinking, that's what we thought. It doesn't really work like that. There's really lots of factors that seem to impact surprisal as well, and also of course givenness that are not really in the same ballpark of concepts to think about. But the thing that didn't work for us at all is that so far we always started calculating surprisal at the beginning of the sentence. So there was really no way to model, for example, co-reference, or well, there wasn't any co-reference in the corpus at all that we could annotate for. So you wouldn't know if this pronoun was just used, to refer to a person, for example, that was just mentioned in the previous sentence. So we have to think of a better model to model that, basically. But one of the foci of the entire SFB is to actually work on this. So this SFB, this kind of large departmental project has been really focused on information theory, also within experiments and stuff like that. But now I think they're also trying to, in these last 4 years, to really come back also to what that, like hook it up to some more traditional concepts in linguistics, like information structure. So that will be one of the kind of cross-project working areas that we're gonna invest on. Yeah.
I mean, why I find that concept of surprisal really interesting is because we have evidence in, let's say, reaction time experiments and then in EU that comes out. And the new work that is, I don't know whether you know of Jakub Szewczyk. He's kind of like in between, let's say, computational linguistics and more what I do now. And they have a recent paper where they looked at one of the tasks that we use is sentence repetition. And then they looked at n-gram frequencies of kind of related to word order and how that corresponds to behavioral data in correct repetition of words. So that's one of the directions, let's say, where this could go, and might be interesting to see actually that connection between behavioral data and corpus data that might tell us actually where to go. Also, I mentioned in the message to John, but Dagmar Divjak and Petar Milin do work which is related as well. I don't know whether you would know of that, but that could be, it's kind of with that sort of information theoretical approach linking corpus linguistics and behavioral data.
I'm really bad at spelling people's names. So I made a screenshot and I will write to you after the talk so I can get some of that information.
I would be really, really interested to see what you kind of come up with, and I'll keep an eye on the data to use it in behavioral studies.
Many thanks. Yeah.
Thanks for the talk.
Thank you.
Okay, great. Some other questions?
I have one, if I may. Thank you very much for the talk, Annemarie. Bedankt. I will do this in English, obviously, not in Dutch. I was wondering if you use like prose and not like maybe more informal writing. Do you think you get, I mean, if you look at information ordering, you know, in speech, I suppose we talk quite differently than we from the stuff we write, right? So I suppose in running speech, we maybe front things more, or, you know,
yeah.
So there's a difference there. I suppose it's the influence of genre and the ratio of you know, different genres in your corpus. So could you say anything on that, on the influence on you know, the relation between information ordering and genre, I suppose?
Yeah. No, I mean, actually, we suspect that there is a lot of variation there. So and that's also why in some ways we don't really want to use the tree banks that, for example, UD provides, because typically they have information, well, they have text that they take from the web. They also have text that they take from fora or from commentary and stuff like that. And all of that is going to work pretty different, we think, with respect to the phenomena that we're interested in. So we really want a more controlled environment. We took prose and the diary because this is what we can get, right? I think it would be almost impossible to get a parallel corpus of spoken data, even though that would, of course, be highly valuable. The only thing that you can get close to is something like TED Talks and perhaps subtitles. So that would be interesting. But we suspect that there is actually really a lot of variation in that respect, that you won't find the same word orders across genres that much, right? There's some basic ground rules that languages, like especially fixed word order languages like English, have, but other than that, you know, there's lots of variation in across genres, we would say. Yeah. I mean, we have kind of within prose, within the prose that we do have different genres, in the sense that some of the books are really full of dialogue. So we could actually try and see if there's differences in the dialogue as opposed to these kind of more prosy parts of the works that we have. And then we have the style of writing that we have across different books is actually pretty varied as well. I mean, this is intentionally so that we can get some of that variation, at least in the written genre. Yeah.
Mm-hmm. Okay. Thank you.
Okay, great. Any other questions? Okay.
I do have a question. So when we are talking about like a closed domain, or like so it's like a very, when you are doing your experiments, it's like a very closed domain, as well as, you know, a very controlled environment you are doing the experiment. So how does that affect, like in real world data, you don't have any control over the domains, or as well as when you do like the languages, they don't have a very controlled environment. So how does that affect your experiments?
I'm not quite sure what you mean or how to start answering that.
So
I mean, is it following up from what Doris said on genres, or?
Sorry?
Is that following up from what Doris said on genres, or no?
Yeah, exactly. That's following what Doris said. So basically, your experiments are in a very closed environment, that your corpus are like very literature based corpus which have the parallel data, and then you basically study the behaviors of the participants, right, to get the cross-linguistic diversity. But in the real world data, when you see the cross-linguistic diversity, then it may vary, right? So like the literature corpus is very different from the maybe could call as the vernacular languages that people speak, and the difference, the cross-linguistic diversity may varies a lot. So do you have any idea like how does that vary, or what difference does that make?
Yeah, so I mean, so what I answered for Dora's question was like, we'd stick to this controlled type of data because that's what we can get. There are other types of data that you could get that speak more towards colloquial language use or spoken language use, but which would be hard to get parallel. So if you would want to create really quite a big corpus, you wouldn't be able to, for example, parse it in the way that we want to do using this the parallelness of the corpus. Of course, we don't know for each of the language. So for each of the languages that we're studying, we wouldn't know how the written language corresponds to word order variability or information structure in other genres in that language, right? So we don't know how to extrapolate from what we study to language use at large in other genres, including the spoken genre. I think this is a problem basically everywhere, right? So if you were doing, for example, an experiment and you're getting people to produce sentences on the fly, then of course you're studying a phenomenon that's different, for example, than if you would get them a written task or if you would study literary materials. So yeah, this is hard to do. Nevertheless, we have a little bit of the spoken genre within the dialogues within the text that we're going to try and make use of. But you know, every project has these types of limitation with regard to data that you can't get out of, unless you have, of course, infinite amounts of time and energy and money. Then everything is possible, but that's typically not the situation that we find ourselves in. Thank you.
Okay, great. So I know you have to go. So I'd like to thank Annemarie again. It's a very interesting talk, a very interesting topic. And yeah, and well, as we'll have our next, the talk will be available on YouTube, and we'll have our next Cardamom Seminar series next month. I think the announcement for that will come out fairly soon. Okay, so thank you, Annemarie.
Many thanks for having me.
Yeah, you're welcome, and have a nice day.